Now let's talk about ways that we can use the periodic table to determine the electron configuration of elements. The periodic table is set up in terms of blocks. So each group or blocks represents an orbital or suborbitals. Alkali metals and alkaline earth metals compose the S block. The transition metals are the D block. And from groups 13 through 18 is the P block. Lanthanides and actinides are the F block. So what does this mean? Any element in its respective block is going to end in that suborbital. Its electron configuration will end in that suborbital. So all the alkali metals will end in S1. All the alkaline earth metals are going to end in S2. The D block, any of these atoms that are in the scandium group are going to end in D1, titanium D2, etc. And you'll notice if you count across from left to right in the D block, you would expect there to be able to hold 10 electrons, and if you count across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The P block, remember, has 3 orbitals, each holding 2 electrons, and it can hold 6 electrons. And so if you count from left to right, 1, 2, 3, 4, 5, 6. So all the elements in the boron group are going to end in P1. All the carbon group elements, P2, etc., all the way to P6, which is the noble gases. So let's put this to practice. If we wanted to determine the electron configuration of silver, Ag, we can use the periodic table. We don't have to rely on this scheme anymore to figure out the sequence of the electron configuration. So Ag is 47. It has 47 electrons, and it ends on the 5th row. So if we start at the top, the 1s is going to fill first, so 1s2. And you can count across from left to right. 1 helium should be above the alkaline earth metals, 2. And then we go to the second row, and 2s. And there's 1, 2, and the 2s. Then we skip on over to the P, and that's still the second row, so it's 2p. 1, 2, 3, 4, 5, 6. Third row will be filled next, and that's the S suborbital, 1, 2. And skip on over to the P, 3p, 1, 2, 3, 4, 5, 6. Fourth row, 4s. Now we're in the D's, so 4s2. And the first D, if you remember, going back to this, the first D is 3D. So after 4s, we're going to fill the 3D. So the first one would be 3D, and you count across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we're going to go back up to 4p. Okay, so the D's are off by -1. So it's going to go 4, 3, 4, and then 5, 4, 5. Okay, so just to show you on this diagram, after 3D is 4p. After 5s is 4D, then 5p. But we don't have to worry about using that anymore because we can just read it from here. So after 3D 10, we're going to go back up to 4p, and we're going to count across 1, 2, 3, 4, 5, 6. And then 5s, 1, 2, and then this is going to be 4D, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if we counted all these exponents, they should equal 47. Now I would like for you to try. If you want to be guided through this, you can continue on with this lesson, or if you want to just pause it, try it, and then check your answer, you can do that as well. So let's figure out the electron configuration for selenium using the periodic table. So selenium has 34 electrons, and we're going to have the first n equals 1 filled first, and 1s2, 1, 2. 2, this is the S block, 2s2. Skip over to 2p, 1, 2, 3, 4, 5, 6. 3s1, 2. 3p, 1, 2, 3, 4, 5, 6. 4s2. 3d10. And then 4p, 1, 2, 3, 4. And that's it.